Today we have with us Rom Kandavel, an ophthalmic surgeon from Encino, California. And he's going to tell us about his work developing a new marker for toric IOL alignment. And Rom, can you tell us a little bit about your background and your practice?
Yeah, absolutely. Yeah, I mean, I grew up in Southern California, although I was born in Singapore. I've been in Los Angeles most of my life. I went to UCLA undergraduate, and then I went to UC Davis Medical School, and then to UC Irvine for residency. And I practiced in Encino, California with Michael Covart and another group of multi-specialty group with a few doctors. And I've been in practice for about 14 years. And I perform, a number of anterior segment procedures, about 600-700 cataract surgeries a year, which is my primary focus. And I came to work with ASIK because I felt there was a need to have the best possible accuracy when it comes to placing our intraocular lenses, as this is an evolving field and there are different people with different access to different instruments. I wanted to have at least the chance to place these lenses on axis, and so my experience was that most degree markers are 10 degrees, which is not, I think, consistent with our goals. 5 degrees is better.
And why is that? Why is there a need for that level of precision?
Absolutely, because for every degree that lens is not on axis, we get a 3% on average reduction in the effective power of that lens in terms of its astigmatic correction. And so in order to have really good outcomes, you have to try to aspire to it being directly on axis. And there's a real, space in the industry where, we're not finding that degree markers match up with those goals. So that's where I started working with ASIK in order to develop a degree marker that had single degree resolution. I think that's been really good. And I'm hopeful that it'll make an impact.
Okay. How did you connect up with ASIK?
Wow, that's a really good story. I had the bright idea, I think probably around the same time everybody else had the bright idea, that you could use the gyroscopic electronic mechanism that's found in your phone to help toric mark for cataract surgery preoperatively. And then after I went ahead and patented that, we did our search, we found that a lot of other really smart people had thought about it a few months before I did.
Yeah.
And so, one of those really smart people was Ravi.
Okay, well, there you go.
And somebody he works with. And so, I ended up getting connected with him through that experience. And then he was kind enough to, instead of stalling out my efforts, he really fueled them. And that's how we came upon some other avenues of improvement. So,
Okay.
Yeah.
So can you walk us through the way that this was developed then?
Sure. I mean, but basically after Ravi and I met and the team at ASIK, we kind of looked for gaps where we could improve things. And one of my ideas was to develop higher resolution in our marking systems. And you can really marry this marker with any number of other marking techniques, but without the resolution it provides, you don't necessarily, have the ability to visualize that intraoperatively. So going from there, I don't know that there's a whole lot of people, in this space that would be able to manufacture a degree marker with this high a resolution. So we had to figure out what the right diameter was and then the right resolution of those markings in order to make it a practical, visually impactful marker. And so that was really quite amazing. And most of that direction, came from ASIK and their engineers and their manufacturing folks, and that's how it came to bear.
So even though you had the idea to translate that into metal, or it's made out of metal,
right,
it required a certain level of expertise, it sounds like, in how to put that together, what it looks like.
The idea was not the biggest part of the product. The developing the product itself from a manufacturing standpoint, I think, is the biggest hurdle that ASIK was able to overcome.
How long did this take before you got to a prototype that was usable?
Yeah, I do remember actually receiving multiple schematics and how the resolution may look, and then we work through the practicality of having those degree markings so close together. And as you can imagine, as you increase the diameter, you widen the spaces between those degree markings for our visual resolution.
Right.
But at the same time, it can't be too big because it has to be practical for the use in the eye. So I mean, that's how it came about.
Okay. So you're experimenting with it now, or you're using it now in your daily practice?
I'm actually using it every single day, and we use intraoperative aberrometry. We also use preoperative marking using Asiko's microelectronic marker. But the aura aberrometer and even other iris registration systems do not have 100% fidelity, and so you have to, in our setting in America, we fall back on those markings we put on preoperatively, not only in case that we don't get enough information to lock on intraoperatively with our aberrometer, but also, because it serves as another opportunity to check our work against another form. And, if there's ever many solutions to a problem, it means that none of them are necessarily perfect. And so that's why we use redundancies within that kind of protocol in order to make sure we're getting it on axis.
So even though you have access to some of the highest technology aberrometers and so on, you still have a certain number of cases where you need this, it sounds like.
Absolutely.
And then also it's a good backup or a good check just to be sure that everything is functioning properly.
If you talk to anyone who uses the aberrometer, in America the most common is the aura aberrometer. One of the things that I think each of them will say is when you have very lower degrees of astigmatic amplitude, the reliability of the aberrometer for the axis is more variable. While you get a stronger signal from a larger amount of astigmatism, which makes it, I think, more reliable, the error aberrometer can vary for even orders of astigmatism that would warrant the lower denominations of the toric and tracker lenses. It's not insignificant, but it's just more difficult to track. And so, and that's because there's a challenge on getting physiologic pressures and maintaining the surface in a way that it can be consistently read.
How often would you say that you need to use the backup system?
That's a great question. I don't think I've ever looked at that officially, but I would say it's extremely high, like on the order of 10 to 15% of cases. I don't necessarily trust what the aura is telling me as the final position of the lens. This is more of a problem in the lower denomination toric lenses like T3, T4s, 1 diopter to 1.5 diopter. That's also the most common toric lens that we place. So I think it becomes very important.
So it actually, even though it's lower power, more patients need the lower power lens. So it actually affects quite a number of your patients.
Absolutely, and I found that. And in fact, we're working now with the aberrometer to look at what the final postoperative reading looks like in comparison to if you take the aura in the postoperative state, even a month or 2 months later, in the pseudophakic physiologic state. So does the aura match what you may read then 2-3 months later when the eye is presumed to be at physiologic pressure in its natural state? Because theoretically, if the aura was reproducible, then you would be able to have 2 measurements, one intraoperative and one then postoperative, that theoretically would be the same. Minus maybe a small change in the effective lens position due to healing, but you still should get the same total spherical power and or the amount of astigmatic correction. If it says it's no rotation required, it should say that then 2 to 3 months later, assuming the lens is not shifted.
Do you have any sense as to how accurate the manual marker that you have is relative to the aura?
So well, that's been looked at, and I think there's pretty good data that when the aura works, that it helps enhance our ability to put lenses on axis. So it is better than I think manual marking alone. But I think both together, are necessary in order to assure that you can do every case with the highest possible accuracy. But certainly both are synergistic. And I don't think anybody can rely necessarily on one without the other.
Right.
But it's an evolving field.
Right.
And then there are different places in the world that have different access to different things that will never see the light of an aura.
Right.
Yeah.
Right. One more question. Do you have any other ideas that you're looking to develop?
Yeah, absolutely. I mean, I think that what we need to do is we need to integrate, from acquisition to application, every step of our astigmatic measurement. And I think there are systems that do that already. But I challenge those who do this separately to allow every single step to have allow enough fidelity that you get an end result that is the same as your initial acquisition. That's where the challenge lies. And so if you can enhance any one of those steps, then you add to the total effect of those steps. And so I'd love to work on better toric marking, better intraoperative axis markers, and even more microelectronic markers. I think there's a lot of room for that kind of technology in a lot of different markets all over the world.
Okay. Anything else you'd like to add or emphasize or talk about that we haven't covered?
I think one thing that we didn't chat about is just like what a pleasure it is to work with this company.
Yeah.
I mean, they're pretty nice people, and they get stuff done so quickly. It's really remarkable. I've worked with people that will say they'll do something and then nothing materializes months and years later. Not because they're not capable, but because they have other priorities. But whenever I've been asked to do something, I've tried to do it as quickly as I can, and I have to say that it's reciprocated in every way.
Well, that's terrific.
Yeah.
Well, again, this has been Rom Kandavel talking about his experience developing new technology with Asik and otherwise too. So thanks very much for
Pleasure.
coming by.
Thanks for your time.
Thank you.
Yeah.
All right.